Hey everyone, I'm Shashank and I'm from the IRIS app team. And today I'll be taking the bootcamp on APIs and remote data source. So let's begin. What exactly is an API? API stands for Application Programming Interface. It's basically a framework or a protocol that allows different kind of softwares to communicate with each other, but it need not just be software communicating with each other. You also have hardware APIs, like when you use the camera app, uh, the image that's being fetched from your camera uses an hardware API to get this stream of bytes and render it on your phone. So it's used to communicate and share data between devices, either over software or hardware. So APIs act like an intermediary, and the best explanation of this can be taken to the posh restaurant scenario. So when you go to any high-end restaurant, as a customer, you are asked by the waiter for what you want, and based on that he gets the dishes you have ordered. So in this situation, you as a customer, let's say, ask for the pasta from the kitchen. The waiter goes and tells the kitchen to to make pasta, and once the pasta is done, he brings it to you. So this is how an API works. You The customer is basically the end host application. The kitchen is usually the server or the hardware that's providing the data, and the API is basically the waiter who takes the request from application to server and brings the response from server to application. And the entire process of how the data is fetched and any additional data is abstracted. For example, when I'm making the pasta, as a customer, I don't get to know how the pasta is made or what and all extra ingredients went into the pasta other than what's obviously there in front of me. And many other hidden ingredients. Probably if it's a posh restaurant, it has like a secret ingredient. All of those are hidden from the user basically. So this is how an API works in a simple way. So why do we need APIs? Not everything can be stored and packaged on app. So in the last video by Nishant, you guys would have learned about Hive local data source. So let's take the example of the To-Do app itself. Now let's say over like a few months I create thousands of to-do events, but all of these are locally stored in my device. Now when I store so many to-do events in my device, it's going to consume a lot of my memory. And If I take that much memory, it's definitely going to give lesser memory for the additional apps, and if I have like a phone with just 64 GB of data, it's going to start affecting the performance of the phone. So I can't afford to store everything within local database. And the second thing, um, if I want to, let's say, change my phone and I want to log in and get data that I had already saved in my to-do app, I can't do this because all my data is stored locally. So it's better to keep it in a remote data source and then fetch it. The second thing is user-based and role-based responses. The best example of this would be, let's say, in IRIS itself, both students and teachers use the IRIS app. The functions that the students use, like buy and sell or courses, these could be common between teachers and students, but the way attendance for the course works for the teacher and student would differ. A teacher can update the attendance, whereas the student can only see the attendance, not change it. Uh, so the role-based responses is another function of the API. One of the main functions of API is to ensure security. If all the data is in the app and some of them are not relevant to the user's role, but let's say the user is able to suddenly access all of the data in the app, the entire data has been compromised. Now if it's an API, I can just limit his access and only send him the relevant data. And the second thing, I can authenticate the user using security tokens or session keys to ensure that only a legitimate user is able to fetch the data. So in these ways, APIs help improve security and they make scaling the app easier. Let's say I have an app that has a list of locations. Now if I just hard code the list of locations and like places to visit, every time I add a new location I have to re-release the app, which is going to take a lot of time and a lot of convincing for people to update. And it's going to exponentially increase the memory as I code more data. However, if I'm going to store it in a remote data source and then use an API to just fetch that data and render it on the app, I don't need to update the app. The amount of code, the core of the app is going to take the same amount of space, and I just have to fetch and render based on the response. So this makes scaling the app easier, so I can add more and more this thing without having to worry about multiple releases and like the amount of data the app is going to take. So that's one thing. There are multiple types of APIs like GraphQL API, REST API, SOAP API, and many more. The one that's most popularly used is REST API. It's basically a framework, and most of software development runs on REST API. So what is REST API? REST API is a framework, which means it's a set of rules on how you are going to write your API and what functionalities your API should have and how it's going to function. It's a stateless protocol, which means when I'm sending a REST API request, the API has no idea of what and all the requests have gone before it. So there's no way for it to know what and all the user has already accessed. Now because of this, this means whenever I'm requesting something from the client, I have to send valid parameters. Let's say I'm fetching the number of books in a particular location for the library API. I have to send the location as a parameter in the API, and these parameters are called query parameters because they are like key value pairs that you are adding to the query for you to get a particular response. So REST API, so this is how REST APIs usually look. They don't retain session data in between the requests, and there are primarily 5 types of REST APIs: get, post, put, patch, and delete. And these are kind of self-explanatory. The get request basically just gets the data from a remote server or like your hardware device, and you can't make any changes to the data you have gotten in the server. The post creates a new record. So basically, let's say I'm creating a new user, I send a post data to add like the valid columns like ID, name, surname, email, phone number. All of these are added as a post request to add a new user to the database. Now put and patch are both used to update an existing resource, but there's a key difference between put and patch. Let's say I have a user ABC whose ID is 2. Let's say I want to update his email from abc@gmail.com to abc@nitk.edu.in. When I do that using a put request, it rewrites the entire record. So I have to pass all the parameters, the ID, name, surname, email, and phone number, and this will be rewritten. The whole record will be rewritten. Whereas if I'm doing a patch request, I just have to pass the ID, which is used to uniquely identify the record, and the new value of the email. So only that column is modified. So that is one thing. And the final this thing is delete request. Kind of self-explanatory. It just deletes the particular record from the remote server. So this is how REST. These are like the 5 fundamental functions of REST API. And now this is an example of the REST API URL. So first there's a domain name, which is used to uniquely identify the server that you are trying to access. Then there's a path, which is going to help you find the functionality. This is so in this case, let's say for the library API, mcnz.com, I want to fetch the number of books at a particular location. My domain is going to be mcnz.com/library/book, and this together will form the base URL of my domain. And then once the base URL is done, it's followed by a question mark, having which then is succeeded by the query parameters. Query parameters are used to pass variables in the REST API, because this is stateless API, so you have to pass information to get a particular response to what you want. So let's say for Toronto, I want like all the books having the title Ulysses. I'm going to add like two key value pairs, location Toronto and title Ulysses. And using this, I'm going to like fetch all the books that are in Toronto having the title Ulysses. Over here, you can see that when I have multiple key value pairs, the query parameters are separated by the ampersand symbol. So this is a basic demo of this is a basic introduction to REST URL. So let's begin with the demo. So for the demo, we'll be using NASA's image of the day API, which is a free API. So there are two kinds of APIs. Ones you can use free, that are open source, and the second ones which are like a paid service. And obviously we are going to be using free APIs here. So in order to use any free NASA API, you have to generate an API key, which is used to identify that you are a legitimate user using the API for like non-malicious purposes. And this is also used to prevent people from just spamming the API endpoint with like endless requests, because if you give too many requests, like millions per second, it's possible that you could bring their server down and no one will be able to get any service. So this is done to prevent all of those. So you'll generate an API key here, which is going to be very important. So you have multiple free APIs in NASA over here, as you can see, but we are going to be using the astronomy picture of the day. So this is going to get like the NASA's picture of the day, and like it's a GET request. Obviously we are only going to be working with GET request today, just to give a demo of how APIs work in this thing, in Flutter. So this part, api.nasa.gov, is going to be the base URL, and planetary/AOPD is going to be like the path prefix. And over here you have various query parameters, which you can use to fetch a specific image. For example, let's say you want to fetch an image of 10th October 2024. You are going to pass a date as a query parameter with 2024-10-10, and you're going to get like the image of the day for that day. Then you can pass start date and end date. So within the range of like start date and end date, you'll get all the images. Then count, you can like get a specific number of images, randomly chosen images that are returned by the API. We won't be using thumbs. And API key is like a very important this thing. As I told, it's going to ensure that you can use the API as a valid user. So let's go through an example query. So this should get us today's API of the day, and we can see the format. So you have date, you have like an explanation which gives like a brief description of the image. You have the URL and the HD URL of the image, which you can access. Then you have media type and service version, which we won't be using. And then you have the title of the image, which is called Saturn at Night. So let's begin with the coding. So to begin with this, we have like a sample app already written here. This is like your basic Flutter app that you have, the increment counter app. Uh, so first, let's begin by so we'll have like multiple what do you call we have like multiple folders within lib core and secrets, where my secret key that I generated for the NASA API is stored. Note that the secret key should be kept completely secret and should never be added in a video or like checked into a repo, because malicious users can use your secret key to perform like a denial of service attack or any of that kind, and you'd be the one blamed for it. So make sure to never check it in, and in order to do this while you're checking it into git, you will just like avoid it over here, secrets, and you're going to like store it, you're going to add it to the git ignore file. And now you can see when I do git init dot, the secrets is not like it's not possible to add the secrets folder into like our git branch. So now let's begin. We have like a basic main page which has not been modified, and then we have like a data, pages and widget, this thing. So let's begin with the data. So I'm going to have like two basic classes here. One is called image model, which will like have like the response type of my query, and I'm going to use this to access whatever responses I get, and then I'm going to have the image remote data source, which I'm going to use to fetch the data from the remote data source, which in this case is the NASA API server. So let's begin. Uh, let's set the fields of the image this time. So you're going to have a title, an explanation, a date, a URL, and a HD URL. And now I am going to create the constructor for this. As you can see, like these are the only relevant fields from this API that I am going to be using. I am not going to be using like the service version or media type. So these fields have been added. Now I am going to write a some JSON function. So let me just write that factory image model dot from JSON. So over here, factory basically ensures that for any image model, the from JSON function, only one instance is created. So when I have multiple image models, only one instance of this from JSON is created, and this makes a lot of sense when I working with large scale applications. Let's say I have 1,000 images that I fetched from the API. I don't want to like create like 1,000 from JSON functions. I just want the same from JSON function to run 1,000 times, and factory ensures that only a single instance of that is created. So this image model from JSON function, it's passing JSON, and as you see, you're like getting like the JSON functions passed here. Now I'm going to write the image remote data source. In order to use the image remote data source, I'm first going to have to add a dependency that's called HTTP package. So this is the package I have, HTTP, and I'll be using this package to make HTTP REST requests, and we are going to now add it to our pubspec.yaml. So HTTP, and we can see the version was 1.1.2 there, so we'll be adding 1.2.2. So once I've done this, I'm going to then dart get, and now HTTP has been added. Now in my image model file, I'm going to import package HTTP as HTTP. Now in my image remote data source, I'm going to have like a base URL, which is going to be static const base URL. It's just going to be api.nasa.gov. Then I'm going to have the static const string path, which is going to be planetary/astronomy picture of the day. Now comes the interesting this thing. I'm going to have a map string comma string called query parameters, and over here I'm going to pass my API key. My API key is currently stored in secrets.dart as secret key. So I'm going to be passing that. And now we are going to write a function which is to fetch image. So future image model fetch image, and now I'm just going to add a date. And this has to be asynchronous function because I have to await the response, and Nishant has already introduced you guys to asynchronous function, so if you don't remember it, just revise to that once. So now we are going to do formatted date. So we are going to have to pass this in the query parameters, right? So if date is not null, I'm going to create a string called date str is equal to date yymdd, and now I'm going to add it to the query parameter. Once this is done, I am going to generate the URI, which is going to be URI HTTP, the base URL, the path, and the query parameters. Now I am going to wait for the response from the HTTP this thing. So we are going to wait for the response from HTTP. We are awaiting the response, and if response.status code is 200, which means that the response succeeded, we are going to generate a map, a string dynamic called JSON, and which is going to decode the JSON response that's been returned by this thing get request. And to use JSON response, you have to use the Dart convert package. And once this is done, we are going to just return image model dot from JSON. Else, we are going to just throw an exception that says it failed to load an image. So now in order to test this out, let's just do void main fetch image. So if this runs fine, I'm supposed to get Saturn of the day as my response. So Saturn at night was my response, and we can see that the same response has been returned. Now we are going to write a second function that's called fetch images list. So it's going to be of type future list image model. So as you can see, you are passing two parameters, start date and end date. Now let's create two strings, start date as a string and end date as a string. Now to my query parameters, I'm going to add both start date and end date. Now my URI is going to be updated based on this base URL path query parameter, and I'm going to await the GET request that I passed with these query parameters. Now if response dot this thing is 200, I'm going to have a JSON list, and we are going to wait for we are going to decode it as a list of JSONs, and then we are going to convert it as a list of map. So this is going to be so I just converted it to be a string map comma dynamic. Now let's just use fetch images and pass the past 3 days of images. Let's just iterate through all the images and print the title. So now when I run the same thing, oh wait, I forgot to write the else block, else throw exception. Okay, so now if there's any error, it should throw an exception. Now when we run this, we can see the past 4 days images have been fetched. So now that we are getting the responses from this thing, let's just remove this function. We know both our functions and our secrets are working. Let's begin coding the UI of the page. So let's create a stateful widget called main page. In main page, I am going to have a function which is going to be future list images image model. So in order to use this, I'll have to import image model. So it's going to be called fetch images. Remember the underscore in any Flutter class makes it like a private function or a private variable. So let's set the start date to a week ago and the end date as today. So this is going to fetch 7 days worth of data. Let's put it as 8 days worth of data, and let this be like a list image model. Images. We are going to have to await this. Now we are going to just iterate to all the images. We are going to create a final list images. Where the image URL is not equal to null. So you only want images where there's no null value for the image. So you always have a picture to show. So you're going to return filtered images. So this is going to be a function. Now for the body, you are going to return a scaffold, app bar, which is going to be your title is going to be NASA image of the week. It's going to be images of the week, and your body is going to be a future builder. So the future is going to be the function that we are going to call, which is fetch images, and my builder will have two parameters: context, which is my current build context, and snapshot is going to be the data that's going to be fetched from fetch images. So I have this much. So first let's see if snapshot dot connection state, which basically indicates what state your function is in, whether it's awaiting something, or an error has happened, or the function execution is done. So if your connection state is waiting, you don't want the user to be hanging there, so you are going to show them a loading widget. So you are going to return a circular progress indicator. Else, if snapshot has error, you are going to just print an error message saying an error has been thrown. Now if it's neither of these cases, you are going to check if else if snapshot dot has data and snap is the if condition. If snapshot has data and snapshot is empty, you are going to return no images have been found. However, if snapshot has data, you are going to return a page view builder. So page view dot builder, over here my item builder is going to have a context and index. I'm going to return a carousel card, that a widget that I have created. And in order to do this, I have to pass snapshot dot data, it's not null, of index. So to show you the widget that I have created, this is just a carousel card. It returns a container that has like my network image, and on top of that I have like a title and a description. The description has been clipped to 3 lines so that it doesn't override the image. And over here the network model has like a null check. So if the URL is empty, which it shouldn't be because I'm passing only images that don't have empty URL, it gives like a image of no image available. So now let's just run this. Let's clear. So I'm starting a mobile emulator. So let's begin by removing my homepage class. This is not relevant to this thing anyways. And now I'm going to replace my home page with main page. So we can see like the app's launching, and now when I launch it, it should ideally start showing. Yeah, so we can see NASA images of the week, and it's loading the data that we are getting. So yeah, you can see Phantoms of Cassiopeia. This was like 1 week ago. The card for this has been generated with the image, title, and a clipped version of the description. So we can see when we slide this side, it's loading the image for the next day. It's loading the image for the next day. The next day. The next day. And the next day. So we can see that this API works. So this comes to the final day, which is today. We can see that this works, but let's say a user wants to see like what date the image is from, and like he wants to see the entire description. So let's create a page for that. Let's call it the image view page. So let's call it the image view page. It's going to be a stateless widget. Let's call it image view page, and we are going to pass a parameter to it of the type image model. Now this is going to be passed into this thing as a parameter in the constructor. Let's build the scaffold for this. So first let's create the string of date, string date str, and this is going to be if image model.date not equal to null. It's going to get the date of that, or we are just going to put day. So now this is going to return a scaffold. In the scaffold, let's put an app bar, which is going to be like the NASA image of the day. And now for the body, we are going to have a column, and the first line of the column is going to have the date. So children So let's tap the date in a padding. Padding is going to be agents constant. So we have a padding, and the padding's child is going to be a text that has the current date. Now we want to give it a particular style, so we are going to use the text style widget to pass the style, which is, let's keep the font size as 12, and let's make it italic. So font style dot italic. This should be a const. So first that, then we are going to wait for then we are going to get the image, which is going to be done using image dot network. Now my src is going to be, first I'm going to check if I can get the hd url. So I'm going to do image model dot hd url. If that is null, then I'm going to fetch the url image model dot url. If that also turns out to be null, I am going to get the default image, which is going to be http dot upload wikimedia image, etc, etc. And let's just remove this. Oh, this should be outside the padding, my bad. Control X. And now we want to put a loading builder. So if the image is, since we are fetching this from a remote data source, we want the user to know if the loading is in progress or not. So if the loading is in progress, we are going to return a circular progress indicator. But if loading progress is null, so basically an error has happened, or a child has and a child has been created, which is your network image, you are going to return the child. So that is there. Once that's done, we are going to add the title using a padding. Let that be of size 24, font weight bold, and let's add the description also. So let that be of font size 16, and let's add a font family to it. Let it be Roboto, and this is going to be our image. Now we have created this page, but we have no way to access it. So let's go to the main page, and let's wrap this with a widget called Inkwell. Inkwell basically allows actions on widgets that have been tapped or double tapped. So you can basically trigger an action based on you can basically trigger the function based on an action. So over here, let's say on touching the image, I want to be able to reach the image view page. So it's going to be navigator dot push material page route. So the builder is going to have a context. First you have to pass context to the push function itself, and then material page route. builder will have a context, and you're going to return image view page, and that's going to be a snapshot dot data dot index. So now let's go to the emulator. Now when I click on Phantoms of Cassiopeia, you can see that I've come to the a new page that I have created, that's called Phantoms of Cassiopeia, and we can see that the image was loading, and once it's been fetched, the entire page has like all the data, but we can see that there's a overflow error, and we don't want this to happen. We want to be able to scroll. So let's just correct this off. So let's wrap the column with a widget, and that is called single child scroll view. So when we do this, we can see the changes here. We are now able to scroll and see the image of the data. So that is, so if we go to any other image, let's say the Cosmic Pat Nebula, we can see that a loader has been triggered. We are waiting for the image to load. Meanwhile, we are able to see the description along with the date and the title. So we are also able to see the image once it's been fetched. So thank you for attending the session, and feel free to reach out if you guys have any doubts. Thank you, and have a great day.